Hello, welcome. We're Scan SMS, your full service marketing pipeline. A little about us. We're a marketing and advertising operations team, Scan SMS, and we specialize in travel and tourism. We manage data pipelines, construct recommendation engines, and develop classification models to identify target markets and campaign optimization. Our team consists of 2 data engineers, Nancy and Saba, 3 data scientists, Shaila, Sahili, and Musimi, all supervised by myself, project manager Colin Moore. Our team offers a way for companies to optimize their advertising campaigns by matching social media to the marketing channel. Our service will extract images, videos, audio, documents, emails, and messages from social media APIs such as Facebook, Twitter, Snapchat, YouTube, Pinterest, and Instagram. We will also ingest marketing data from the various channels our clients run their campaigns. These will consist of CSVs, HTTP GETs, and other proprietary APIs. We'll use Azure Cosmos DB to generate JSON documents, which will be used to index the unstructured documents in SQL. We'll store the documents in various Azure-enabled databases such as MongoDB, Cassandra, and Graph. We will perform analytics on campaign data by utilizing the Azure Synapse link, which allows us to run machine learning models without consuming any of the throughput provisioned for the operational data. The results of the machine learning models will be written to SQL as table data. Our machine learning models will be a recommendation engine to match user content from the social media content to the campaigns, to match user categories to the campaigns as targets, and to optimize campaign channels. We'll package the campaign analytics into reporting dashboards. The data engineers, Saba and Nancy, will handle the data from the time it is extracted using the APIs to deciding how to transform and store the raw data from the provided APIs within Cosmos DB. The data engineers make sure all the inputs connections are using the current API versions. The flat file automation is in place, and this includes VPN connections, SFTP, FTP, or FTPS services, making sure that they're running. They'll also manage the RU subscription levels for each client and monitor the service logs. All data scientists, this includes Musumi and Sahili, are tasked with an analysis of ready-to-use components available from our major cloud computing service provider, Azure, once the data enters Power BI. The deliverable is the recommendation which user content from the social media sites should be applied to the campaigns to improve in performance, and which targets clients should be used in future campaigns. My task is to oversee the entire project and take care of any management and maintenance issues, deadlines, customer training, and customer support. Nancy will take over from here.
For this project, our data will be asynchronous, which just means that the latency and throughput will not be a main concern for us. Additionally, we'll use both nominal and unstructured data within this project. We'll be expected to abide by data privacy policies from Facebook, and to add an additional layer of privacy, we'll have encrypted servers. Managing advertising campaigns across multiple channels independently is effort-intensive and difficult to scale. Lead generation is typically dependent upon the channel selected with limited capacity to perform rich analysis on broader variables. Social media APIs provide robust information about their users, but are typically siloed for in-channel advertising. We would like to create a seamless way for companies to optimize their advertising campaigns. We will create a managed pipeline that will ingest campaign data, social media data, and user-generated content assets. We will use machine learning to generate lists of targets for advertising and recommend campaign assets for specific channels. We will deliver the results of our recommendation engines as reports and dashboards. Here we have our full pipeline. In the first step, we will be using Facebook's API to ingest user comments like videos, likes, and images. Second, we will ingest CSV files from the marketing channels. Third, we will rely on Cosmos DB to index the data as a JSON file. Fourth, the SQL API connector will store the indexed JSON files and flat files as tables. Fifth, Gremlin will store the media content from Facebook. Sixth, Azure Databricks will perform analytics and machine learning algorithms. Seventh, Cosmos DB will join the analytics and machine learning results. Lastly, Power BI will visualize the campaign performance results and reports. Since we are using Azure for each of our components, the service metrics guaranteed for our throughput will be the same across all of the components. The read latency for all consistency levels is always guaranteed to be less than 10 milliseconds. The average read latency is typically 4 milliseconds or less. The write latency for all consistency levels is always guaranteed to be less than 10 milliseconds. The average write latency is usually 5 milliseconds or less.
This component will access Facebook user information from the Facebook API and request the images, videos, likes, comments, and user attributes as schema list data. Then we'll import CSV flat files from the marketing channel as table data. The inputs pass directly to our Cosmos DB store, which applies the transformations to the data. The transformations are defined at the specific functional nodes in each component in future slides. Our input will be unstructured data, which is extracted from Facebook API, and flat files from marketing channels, such as images, videos, and messages. Output will be JSON, unstructured data, and table data. This component will use Cosmos DB to convert social media data to JSON files. These JSON files will be indexed, which will make them queryable, much like we would within a relational database. Cosmos DB will grab documents from data stores, from various data source points. Additionally, Cosmos DB will allow us to scale upwards using built-in API connectors. Our input will be unstructured data, which received from Facebook APIs and marketing CSV, such as images, videos, and messages. Output will be JSON, unstructured data, and table data, and SQL, like tables containing the JSON indexes. Gremlin stores massive graphs with billions of vertices and edges. We query these graphs with millisecond latency and evolve the graph structure as we apply machine learning and analytics to determine the appropriate advertisement campaign for particular users. Inputs will be raw media files, unstructured, and schema-less data. And for output, in step 5, schema-less data that contains raw media files indexed in JSON format. After that, in step 7, joins table data of intelligent content recommendations to improve campaign performance in current ad operations and campaign data.
The SQL component stores flat files as tables, and it stores JSON indexes as tables. We plan to store machine learning results that identify the significant features that inform us of users' social media behaviors and patterns. This will help to improve campaign performance in future ad campaigns. The input of this component are flat files and JSON indexes, while the output produces SQL tables and views. With Databricks, we are able to manage, parse, and process large quantities of user-related data to perform simple analytics and run machine learning algorithms, such as cluster analysis. These analyses will allow us to group users with similar social media usage and behavior patterns, which in turn improve the campaign performance on current ad campaigns and improve targeting in future campaigns. The inputs will be SQL tables, while the outputs are written to SQL tables. Power BI will connect with Cosmos DB to produce interactive dashboards and reports that will be tailored to our clients' intended purposes. We provide clients with no SQL knowledge access to view these dashboards. We provide clients with SQL knowledge access to SQL tables so that they can perform their own query operations. The inputs are SQL tables and views, while the outputs are reports and interactive dashboards with connections to Cosmos DB that were customized according to each of our clients' needs.
Our organization has created this tool for our clients' use. The end users of the data aggregation, transformation, and analytics will be marketing professionals who will be segmenting consumers for marketing campaigns and tracking the performance of the campaigns. The end users are in travel, hotel, aviation, and casino industries. The most common application for the pipeline will be the performance visualizations, dashboard creations in Power BI, report writing, and the accuracy of the business intelligence and machine learning value adds our service provides. Also, matching our clients' advertisement campaigns to the appropriate target market over social media, mass emails, or text messages. Hmm. Like most advertising companies, we want to be able to help our clients to improve their marketing strategy by directing the appropriate advertisements to the correct target group. Some of these advertising companies have implemented pipelines similar to ours, such as Mixpanel, Singular, Confluence, Reverie, and Metadata. Each of these companies manage their marketing pipelines similar to our company, but they do not perform content generation by using machine learning to improve their advertising operation that they use for their target groups.
Let's talk about the challenges we have faced to build our pipeline. One of the first challenges we faced was defining the application use of our pipeline. We were not sure as to whether we should make our pipeline a general one size fits all versus a narrowly specific pipeline based architecture. We decided that simplifying the pipeline was the best course of action. The next challenges was coming into agreement about which component we should utilize as our primary area of focus. No one in the group had an in-depth knowledge of data pipelines, so it was extremely difficult to determine what qualified as a component and whether or not it would have served the purpose that we intended it to carry out. Prior to our meeting with the stakeholders, we found that most of us were unsure of the level of detail that was expected to establish the fictional company that we represent. Initially, we thought that there needed to be an elaborate level of detail, but we soon found out that that was not the case. Now move to the last challenge. One of the benefits to Cosmos DB was that it had many useful API connectors. However, our problem was determining which of the many API connectors we should keep in our pipeline. We reviewed our data type inputs and came to the conclusion that we should only keep Gremlin and SQL data warehouse within our pipeline. Reducing the number of API connectors in our pipeline simplified our work. Thank you for taking the time to consider our solution.